Hey everyone, welcome back to the Smart Tic-Tac Python project tutorial. So picking up where we left off the last time, so far what we've made is a single player tic-tac-toe board. It just shows the board and asks a cell number, and if I enter 6, then at the 6th position my mark would be placed, and then it asks me again. I enter 1, it comes at the 1, so on and so forth. So currently this game does not have a second player, the computer, neither does it have a winning uh, logic. So let's go ahead and implement that. So what we need to do is just create a method which we can call board, and let's pass it winning, and let's pass the board argument inside as well as the player for which we'll be checking the winning condition, and then we can just have a list that is the all possibilities of winning positions. And since this is tic-tac-toe, there are countably finite, so I've copy pasted this because writing this would be cumbersome now. Oh, so the only thing this is doing is it's just a two-dimensional list with each row containing the possible coordinates for winning possibility. So this one is 0, 0, 0, 1, 0, 2, which corresponds to the first row. This one corresponds to the second row. This one corresponds to the third row in here, in this one. The first one for this, the second one for this, and the third one for this, so on and so forth. This is for the first column, first 3 columns, and then the last 2 are for the diagonals. So we have our possibilities for the winning. The next thing we can do is say for row in winning positions, we declare an empty variable, empty list, and for each position inside that row, we will take out their values. That's called the tuple unpacking. Let's just call it pos for now, and we will add them. We'll add their board's value inside of our temp, so that our temp now has whatever the value that was present inside the board at this variable. Yeah, you could say that. I mean, sorry, position, not pos. Yeah, my bad. We're taking this position and unpacking its values inside XMI, because why I say unpacking is because each single element inside the list is a tuple, and when you take the 2 values of a tuple, that's called tuple unpacking. So we have temp.append, and the next thing what we'll be doing is checking whether the temp's first value equals to the player value provided, and whether the temp's count, the number of times the value 0 appears inside temp, is equal to the length of temp. I mean, I could just write 3 here, but it's up to you. You can go ahead and write it as in any way that you want. There's nothing much more fancy about that. And we can return true, which would mean that the value that we provided here, the player that we are looking for, it occurs at the first position, and it occurs the times 3 times, first position, second position, or whatever the third position is. It occurs all of the times, and that's why it's a winning condition, so we return true. Unless if we never hit that, then at the end we just return false to signify nobody has won yet. So we have our win condition done. So let's go back here down inside the main function and get ready to implement our take the user input. We put this on to do last time, so let's get this done with. So if you begin with, what we'll be doing is first we'll be asking the player what they want to be. So let's just give a player key and ask them for input. And let's write something fancy as what would you like, not like to be. And we can just enter \n so that it goes to the next line, and whatever they enter, we will be taking that as an upper, so that we don't have to actually have a problem like whether it's in lowercase or uppercase. So once we have that, and if you want to, this is an optional step. If you want to make sure that your user always enters the proper value, what you can do is just start a while loop and say while player key dot lower is not equal to x, and player key dot lower is not equal to O. You can just keep bugging the player key to input, enter proper value, or enter proper choice. It's up to you. And again, a black backslash n. And yeah, this again needs to go in uppercase. So this is totally, it's up to you, like whether you want this or not. And there's lots of other ways of implementing this as well, but I just did the most rudimentary and maybe not so efficient way, but you get the point. So once we have a player key, and then what we can do is say if the player key is equal to x, then we say, then we create a variable comp key who gets 0, else comp key, comp key would be x. That's how it works. If you take x, it gets O, vice versa. And now what we need to do is, like, we can add a couple of statements here that just say, hey, print you have taken, and let's just make it a formatted string, and we can say you have taken player key, and then say F again for formatted string, and computer gets the comp key, and that's it. That's the main logic for the implementing the asking user and what it'll take, and the computer getting the other thing. Now, from here on out, what I'm about to do is basically your choice. You may want to do it or you might not want to do it. So what I did in my actual game was whoever took X would always go first. So you can make any way, like you can always make the player go first irrespective of what they choose. But if you want the computer to go first, you can just not the computer, whoever chooses X, then the computer gets the O here. So just create a variable. I just put it as computer turn and set it to false. Otherwise, if the computer gets the X, set it to true. That way, when you are starting your how do we put it? But before starting, let's just show the board one so that the player gets to see the board before starting. And yeah, from now on, you'll need to pass both player key and comp key as well. We'll be making some changes in show board above as well. So before that, we'll do while is empty. Go here and we'll first check the condition. If comp turn, like is comp turn true, then that would mean that the computer gets to go first. And we haven't yet created this function where we pass in the computer turn function hasn't been created yet. So don't worry, we'll create that. But for now, let's just let's just put it like this. It shows an error, of course, because that's not done yet. And once the computer turn is done, what you can do is again, then set it to false, so that otherwise, every time the loop starts, the computer will keep on getting 2 turns. So once that's done, that's done. You don't need to worry about that. And then as usual, you can just have another computer turn and give it a player key and the comp key. And with that, like, you've basically done all of the important and related needed stuff inside the main game's loop. And yeah, one more thing, of course, you need to check at every iteration, has the game ended? Has anyone won? So we add an if statement. If board of win of, let's say, comp, or win of board of human. If that's done, then you just break out of it, and for the time being, let's just print out a game over. If you would have noticed, inside of the win function here, I did not provide the computer key or the player key. Now, as to why I didn't do that is because if you recall, we are not actually entering inside our board in place of this an actual string of X. We're not doing that. Instead, we are just inputting a +1 or a -1. Why? Because it makes our work a whole lot easier. That's what we used here, human +1 and computer -1. So that's what we'll be doing. So yeah, coming back to Showboat now, what we need to do is make some changes or kind of like additions in Showboat as well. So we'll add a computer key over here, comp key, and before that I need to enter a comp key, hold on, comp key here as well. So that gets taken care of, and now we can just copy this pretty much and paste it here, and instead of +1 we can just go -1, and the same thing happens. Now if you ask me why I actually did that instead of just saying if it's either +1 or -1, I could just print this, because later on down the line we will be adding coloring to it, so it'll be helpful if we actually it will look nice if we add different colorings for the human as well as the computer. So far we have done our showboat. Our showboat's totally done. Our winning is done, and the only thing that's remaining is the computer turn. Now, what we'll need to do for the computer turn is we'll go back to the computer turn, and yeah, before we go there, let's just make sure that after every time player's turn is called and player's value has been entered, let's just call showboat and give it the board and the player key and the comp key so that it all works fine. Wait, why is that? Okay, yeah. And in every time, whether it's player's turn or computer turn, both of them need to have the player key as well as the computer key. Oh, the player turn is taking the computer key here as well, so make sure you do that. So once all that is done, why? Because you need to pass these two values inside the showboard here to make sure that they get passed on for proper display later on. So let's now implement our computer turn. And for now, we'll just be keeping it short and not so intelligent. We'll later on increase its intelligence. Maybe in the next video, not now, because we're already a lot ahead, and let's just create a basic one. So let's first do the same thing. If is empty of the board, then what you can do is yeah, pretty much is equal to 0. There's nothing basically much difference here. And once you have done that, what we will do here is instead of we'll just put it as a to-do, as make the computer smarter. We'll be implementing the minimax algorithm here later on. But for now, let's just go ahead with a random choice every time. So never mind. The computer always has to be random at this point. So let's just give it our I value, and we can give it a random integer from 0 to 2, similar to j, 0 to 2, and yeah, it's showing the unknown error because we haven't imported randint. So let's just go up here and we can implement randint from random import randint. So there we have it. So now you have randint available and it accepts that. We have two values, I and j, and now what we can do is just say, if, let me just make this in the center of the screen, if both of I and j is equal to 0, then you can happily go ahead and assign that value. Both I, both j would get. Now what you need to be careful of is not say comp key, because comp key would be a string value such as x or such as o. We don't want that. What we actually want is just comp. Why? Because comp is the value of -1 that we decided here, that is actually being changed behind the scenes in the board. So you need to keep care of that, because I ended up making a lot of mistakes when I was building it the first time. So with that out of the way, else we can just say print the computer chose wrong and forfeited its chance. Like, we can just say that, and we can show the board, and that will be all. Yes. Yes. So we will not be worrying much about what the computer does, because at this point it's just an extremely, extremely dumb machine, because it doesn't care at this moment like what it's choosing and what or not. So let's just try running this, and it should work basically. So it asks what would you like to be, and let's say I enter something wrong like T. It says enter proper choice, I say A. It says enter proper choice, I say B. Enter proper choice, and if I take O, and then it says why bool object is not callable. Which line? Hold on. No, that's the main. If I go here in 116, it says if comp. Oh, I said comp turn. Wait, what? Oh, I should not have given this comp. Let's just call it comp first. That way there will be no confusion, because it's getting, I gave the same name for the boolean as well as the method, and that's where it got confused. So let's just run it again. We know it works properly, so let's just give it an O this time. And whoa, we just keep getting errors, don't we? Local variable Compton reference before assignment 128, not 128, 116 again. Whoa, who gets what? What's happening? What's wrong with it? If comp first, then comp turn. How is this before? I have a comp turn defined here. Hold on. If comp first. Oh, I did this again. I need to change it here as well. So yeah, now it's all resolved. I mean, now the yellow lines are gone. Whew, just a few names will kill you. Okay, so I take O, the computer gets the X, and as the X is always supposed to go first, it just shows me the entry board, and then the computer makes a random choice here in the middle. It took 5 apparently, so let's go. I'll try taking 3, and it immediately took 6. Okay, it's about to win, so I'll try to stop it, but it's not actually gonna win. It's choosing at random, so there's a highly unlikely chance it'll end up at 4. So I'll give it a 1, and let's see. Of course, it took 7, because this is just randomness. The computer chose wrong, forfeited its chance, and I won, and that's why it exited the game saying game over, because I filled the entire row. So we have a working winning function. We have a not so smart computer turn over here, which just works on choosing random numbers, and that's pretty much the basic functionality of your entire tic-tac-toe. So I'll stop the video here, and the next one we'll be taking a look at how the minimax function works and how we can use it to make our tic-tac-toe a lot more smarter. Give it a real challenge. See you next time.